Next up in our chapter on reasoning is conditional statements. So we're going to be talking about a specific type of statement, which is basically an if-then statement. So for example, if it's sunny outside, then I'm going to the beach. So that's basically your conditional statement. All right. We're also going to use a kind of notation, and we're going to talk about a conditional statement in two pieces, which will be the hypothesis and the conclusion. So let's first write down the definition. Okay, so again, our conditional statement is basically a sentence written in that specific format. If something, then something will happen. So for example, I have this conditional statement, if it is sunny outside, then I will go to the beach. So that very first clause, right, the part that comes after the if, so starting with it is sunny outside, this is what we call the hypothesis. Okay, and we use the lowercase p to represent the hypothesis. Don't ask me why it's p, it's just something that we've been doing in geometry, okay? So the hypothesis, which you can also call the p of the conditional statement, is always the piece that follows the word if. So notice how it doesn't include if. Okay, so if our hypothesis is true, meaning in this example, if it is sunny outside, then the second piece will happen. I will go to the beach, and this is what we call our conclusion. So this is vocabulary you're going to want to know. So if you look down at example 1, you'll see the first, oops, I can spell conclusion. So again, if you look back down at example 1, you're going to notice one thing I'm going to ask you to do is identify the hypothesis and the conclusion, okay? So this conclusion, we can also call Q, so we use this lowercase q to represent that. Again, same deal with the P. Not sure why it ended up being Q, but in general, you're going to see P's and Q's. You're going to see the word hypothesis and conclusion. So I want you to know the notation, because the notation you're going to be seeing throughout our work with deductive reasoning, which is what we're going to get into in this chapter as well. So the way you can represent this conditional statement, you can say, it's an if-then statement, or you can also use this arrow notation. So P, arrow, Q. So this means if P, then Q, basically. So if P, then Q. All right. I also want you to think about making sentences into conditional statements. So we'll get into that in a little bit, actually. So I will pause right there with that. So the second vocabulary of the day here is truth value. And it might sound like, well, what does that mean? Is it 80% true, 100% true, 50% true? It's not that crazy. It's basically, is it true or is it false? So that's what a truth value is. So don't get caught up with the terminology. If you see determine the truth value, you're just telling me, is it true or is it false? Let's go ahead and write that down. Okay, so again, you're just going to be able to tell me if it's true or false. Some things might be super obvious, like all even numbers end in 2. Clearly not true. That truth value of that statement is false, right? So that's what you're thinking about when you see in the directions to determine the truth value, all right? Finally, logically equivalent statements just mean they have the exact same truth value. So you can have 2, 3 statements that are all true, then they're logically equivalent. But if one is true and one is false, they are not logically equivalent. So let's go ahead and write that down too. All right, so hopefully pretty straightforward, this vocabulary. Again, logically equivalent, statements that have the same truth values. Okay, let's go ahead and take a look at our first example. So we want to identify the hypothesis and conclusion for each conditional statement, determine the truth value of each statement. If false, provide a counterexample. So this word counterexample we have not talked about yet, but hopefully it's pretty intuitive. So what this means is if you have something that you know is false, you're giving me a specific example proving a conditional statement is false. So again, you want to be very specific and detailed. You don't want to say some, you don't want to say sometimes, but tell me exactly when a counterexample could happen. So for example, if you think back to that earlier statement, if a number is even, then it ends in 2. You can give me a specific counterexample saying, no, 14 is an even number that ends in 4, not 2. But you wouldn't say some numbers that are even don't end in 2. You want to give me something detailed. All right. Let's take a look at example 1a. And oops, I have a typo here that I did not fix earlier. So you want to make sure to cross out that extra I. Okay. If this month is January, then the next month is February. So let's start by identifying the hypothesis and the conclusion. So remember, the hypothesis should come after what word? Right, it should come after if. So we don't want to include the word if, but this entire phrase after if, this month is January, this is going to be our P. This is going to be our hypothesis. All right? That means the next phrase that comes after the word then is our conclusion. Okay? So if this month is January, should indicate your hypothesis, remembering again, the if is not included in the hypothesis. The word then gives you the hint, there's your conclusion. So my conclusion would be the next month is February. Okay, so let me just clean that up. So we're going to clearly label, you can label P and Q like this to help you organize your thoughts, but I want you to clearly write out hypothesis and conclusion. You can use P and Q to identify that, but I want to actually see the words. So let me show you what I mean. Okay, so again, very clearly labeled hypothesis, conclusion. You can again use P and Q if you want. I suggest highlighting if it helps you break down your thoughts, right? But then again, I want you to write it out separately, okay? So now that we've identified the hypothesis and the conclusion, to determine the truth value, you always want to look at what the hypothesis is. So that's the condition. No matter what happens, the hypothesis will be true. Okay, so we're always going to consider if this month is January, then is the conclusion going to work out? So if this month is January, that's we're taking as given, right? Then will the next month be February? That's how you can determine the truth value. And in this case, if it's January, next month should most definitely be February. So I want you to tell me the truth value. Here we're going to say it's true, right? All right. And moving on to the next one. So if you are a girl, then you have long hair. So take a moment, let's identify the hypothesis and the conclusion. Okay, well, hopefully what we found that the hypothesis is you are a girl, and the conclusion is you have long hair. Remember again, we do not want to include the words if and then. If you include the words if and then, you'll actually get deductions. All right, so remember again, very clearly write out the hypothesis and clearly write out your conclusion in your words. All right, but remember, looking back at the directions, we also need to determine the truth value. So just like before, remember to go back and see, did I answer the entire question that I was tasked to answer, right? So here we need to determine the truth value, and if false, provide a counterexample. So clearly, I hope pretty clearly, the truth value of this statement should be false. How do you know? This is where that counterexample comes in. So I want you to be specific. So remember, don't just tell me, I know a girl who has short hair, but try to give me a name. And in this case, if you pick someone from the class, that'd be awesome because that's someone we all would see. But I'm going to pick someone that hopefully we've all seen before. And I'm going to say, Mrs. Rambo is a girl. You might say woman, but if for all intents and purposes, she does fit the category of girl, right? Is a girl who has short hair. So you want to refute both pieces. You want to show me an instance where the hypothesis is still true. So Mrs. Rambo is not a guy, she's a girl, but she doesn't have long hair, she has short hair. So that's what you want to be careful with your counterexample. The hypothesis, no matter what, shall always be true, even in your counterexample. But then you'd show me that the conclusion is false. All right?